Hello, so in today's video, we're going to look at solving logarithmic equations, so equations that have logarithms involved with them. So we've got two equations here which we're going to try and solve. The first one here, ln of 3x minus 4 equals 5, and the second one, log base 2 of 1 minus x equals log base 8 of 8x minus 10. So we're going to solve both of these equations. So we'll start with the first one. So ln 3x minus 4 equals 5. So how would we solve this one? So you want to try and find x. We're going to have to get rid of this ln function. So we need to apply the inverse of the ln function, which is raising both sides to a power of e. So remember that e to the power of something is the inverse of the natural log, the ln function of something. So we get e to the power of ln 3x minus 4 equals e to the power of 5. And the exponentials and the logarithms just cancel out. So you get 3x minus 4 there equals e to the power of 5 there. So we get that. And then we can just rearrange this to make x subject to the formula. So 3x is going to be equal to 4 plus e to the 5. And so therefore that means that x is going to be equal to 4 plus e to the 5 over 3. And that would be our solution there. So that's the first one. Obviously, if you had a question which asks you to give the answer to a certain number of significant figures, then you just use a calculator to work out what it would be. So we'll go on to the second one. So the problem with this second one here is that this second one here has logarithms in different bases. So it's got a logarithm of base 2 there and a logarithm of base 8 there. So we're going to have to deal with this. So if you remember from our laws of logarithms video that we did, so remember that if you have a logarithm of base a, for example, of x, then this is the same as the natural log of x divided by the natural log of a, the base. And in fact, this is true for any base you like. So let's take log base, say, of x, and let's say that this is equal to, well, we can say that this is equal to log base of b of x divided by log base of b of a. So it doesn't matter what your base is here. This result is always true, these two results here. So ln is just a log of base e, but you could have a log of base b, for example, or any number lesser you like. So therefore, what we're gonna do to this equation here is just use log base 2. So we know that, I mean, I notice here that 8 is the same as 2 to the power of 3. So let's convert everything into a log base 2. So on our left-hand side, we've still got this log base 2, 1 minus x. But this right-hand side, we can rewrite it like this. So we can write it as log base 2 of 8x, so the argument of the function. So 8x minus 10 divided by log base 2 of the base of this function there. So log base 2 of 8. So what we know is we know that log base 2 of 8. So what power do you need to raise the number 2 by to obtain 8? That's going to be 3. So we get log base 2 of 1 minus x equals a third, because we're just dividing this by 3. So a third of log base 2 of 8x minus 10. Okay, so we've got that all sorted out then. Now, what we want to do is we've got this third in the way of our, sorry, I'm just going to try and move this to the side a little bit. Yeah, so we've got this third in the way of our logarithm there. So we're just going to use our laws of logarithms now, and we're just going to raise that, bring this constant on the outside to the power of the inside there. So we get log base 2 of 1 minus x is equal to log base 2 of 8x minus 10, and that's all to the power of 1/3 there. So we get that. So then now what we can say is, well, we've got two functions which give the same value, so they are the same. So that means that if we raise both of these with a base of 2, so remember log base 2 has an inverse of 2 to the power of 2, so log base 2 of x is an inverse of 2 to the power of x. So we can raise both sides to a power of 2, and that will get rid of the log function. So we're just going to be left with 1 minus x equals 8x minus 10, all to the power of 1/3. So then what we can do now is we can cube both sides. So if we do that, we get 1 minus x to the power of 3 is equal to 8x minus 10. We can then expand the brackets on our left-hand side. So if you like, you can use the binomial expansion to do this, because if we do that, we would get 1 and then minus 3x plus 3x squared minus x cubed is equal to 8x minus 10. You can then now rearrange this into a cubic equation. So we're going to get x cubed. So adding the x cubed to both sides, then taking away this 3x squared, so take away 3x squared. We're going to add 3x to both sides, so plus 11x. And then we've got minus 10 there, but take away a 1 there, we get minus 11 equals 0. So you get a cubic equation. I'm just going to use the calculator to solve this because you don't need to know how to solve cubic equations. You don't need to know how to solve cubic equations by hand. I mean, if they do say, like in part of the question, for example, f of let's just call this here f of x, this function here f of x, for example. If they were to say in the question f of 2 equals 0, then you know that x minus 2 is a factor, and so you know that x equals 2 is one solution. So then you can use that to factorize out the remainder. But I mean, in this question here, let's just say that they don't tell you that. So you can just use the calculator to solve this. You've got a polynomial degree 3. Your a value is 1, your b value is minus 3, c value 11, d value minus 11. Solve that, and we get one solution. So we get x equals 1.24824 SF to 4 significant figures. So that's the solution of this equation there. So again, when you get a cubic like this, you can just use the calculator to solve that. You don't need to know how to solve cubics by hand, unless they give you one of the solutions, in which case you can then use the factor theorem to factorize. And we did the factor theorem in previous videos, so you can go to the algebra playlist where I've done videos on using the factor theorem and solving cubics using factor theorem. But yeah, that concludes today's video. It's just a brief couple of examples on how to solve logarithmic equations, so equations involving logarithms.